In this video, we're going to look at how to find the maximum value or the minimum value of a function using the TI-84 graphing calculator. Before I look at the first problem, let me just remind you that if you have a model, let's say you have a profit function that looks something like this. Okay, and this continues over here. And let's say at this point, suppose the model is a parabola, it opens down, and let's say this vertex is at hk. And of course, because we're dealing with money, we're interested in positive values of h, x, y, whatever variables these are. And the k will be positive. Okay. So in this particular case, if you have a model that looks like this, the maximum value of this function is going to be this distance right here, which is k. Okay. So we can say that the maximum value of this particular function occurs at x equal h, and the maximum value is k. Okay. In the other case, if you have a parabola, it opens like this. Okay. This point, say that's the vertex, that's the point hk. Again, in the same way, we want the h to be positive, we want the k to be positive. So in this case, you can see the minimum value of this function is going to be this distance right here, which is k. So we can say the minimum, if this is a cost function, we can say the minimum cost occurs at x equal h, and the value of that cost is k. Okay, so y equal to k. Now, if that's the case, you don't really need a graphing calculator. You can find the vertex and solve the problem. There's ways in basic algebra, you learn how to find the vertex of a parabola, you can solve the problem. But in some cases, you might have a situation where your function looks something like this. It's not a parabola. It might go like this, and then go like this, and then it goes out like that. But maybe the interval in question maybe goes from 0 to just, say, this particular value right here. Say over here, it's not possible to go to that point, okay, any of these values over here, even though the function continues to go out this way. Then the maximum value in this particular interval is going to occur at this point right here. Let's call it hk again. It's not a parabola though. So in this case, the maximum value occurs at x equal to h, and that maximum value is this distance right here, which is k. In this case, you have to use the graphing calculator to solve it, or you can use calculus, okay? But here we're dealing with algebra, so we're not going to use the calculus. Okay, so let's just do this then. Now let's look at the first problem. So we have the height of a ball in feet thrown with an initial velocity of 80 feet per second from an initial height of 6 feet is given as a function of time, t in seconds, and it's given by this model. And you can see that's a parabola. You can easily solve it by just finding the vertex. Okay. In calculus, you work a lot of problems like this. You take what is called the derivative of this, and you get your velocity function. Okay, but here we're just dealing with basic algebra. Okay, so let's look at this one. It says determine the time at which height is a maximum. Okay, at what value does that occur, and what is the maximum height? So we just need to find the vertex. Okay, so we're going to use the graphing calculator to graph it. Okay, and I'm going to use, instead of t, I'm going to use x. You can, the s of t is used because of time, and s is, of course, distance. We're just going to use regular variables x and y here. So we're going to use the graphing calculator, and I already have the function entered just to save time on this video. Okay, so minus 16x squared instead of t, I'm using x plus 80x plus 6. Okay, so if I just hit graph on this, I get something like this. Okay, and that's because the values could be large. So if I look at the window here, this goes from minus 10 to 10. That's your standard intervals, and the y from minus 10 to 10. Okay, well, we know that x has to be positive, so we can change this, and you might have to do that in some problems. Okay, The maximum value of x, not sure right now, but I'm going to leave it there. I know y has to be positive, so I'll go ahead and change that. Come down over here to 0. And then the y, in this particular case, could be large. I'm just going to put 150. You can experiment with this. Okay, 150. Okay. We'll take it back. I want this to be 0. Okay, so this will be 0. And then the other one I'll make 150. Okay, hit enter, and then I'll graph. Okay, so now I got something that looks like this. Okay, it's a parabola, so I know that the maximum value occurs at that particular point. So I go to second, and then in the trace, I'm accessing the calculate function. So hit enter. So I want, if you're dealing with minimum, you use the number 3. You leave maximum. In this case, we use 4. So you hit 4. And then I did something like this in another video. Okay, so we need this little cursor here on the left side. What's the left bound? So I need to put it to the left of where the maximum point is. So right there, and then I hit enter. And then I go, once a right bound, so I go to past that vertex over here, hit enter. Now once a guess, you can ignore that and just hit enter again. So it tells me maximum x equal to 2.5, y equal to 106. So this is telling you that the maximum value is 106, and that occurs at a value of time. Remember, here we're dealing with time, x equal to 2.5 seconds. Okay, so we come over here, it says determine the time at which height is a maximum. Okay, that would be 2.5 seconds. Okay, and then for part B, what is the maximum height? Okay, well, it's 106. And here we're dealing with feet. So it's 106 feet. And if you were dealing with a minimum value, you would do the same, basically the same procedure. Okay, so let's clear this. Okay, and let's go to the next one. So this one says an open box. Okay, so let's consider an open box with a square base. Okay, so this is the square base right here. Is to be made from a piece of cardboard 24 inches. So this is the piece of cardboard 24 inches. Okay, so it's 24 inches. And that's all the way around, 24 inches, all 4 corners, 4 sides. So again, an open box with a square base is to be made from a piece of cardboard 24 inches on a side by cutting out a square from each corner and turning up the side. Okay, so let's suppose that from this corner, I'm going to cut a piece out X. And then over here in this one, I'm cutting out a piece X. Okay. And then over here, the same thing. This side over here, and then those are going to be turned up to form the open box. So you can see then that each side then is going to have a length of 24 minus, well, x and x, so minus the 2x. Okay. So you can see when you turn these corners up, the base is going to be a dimension of 24 minus 2x inches. And of course, because you're turning it up, the height of the box is going to be x inches. Okay? So now, express the volume V of the box as a function of the length x of the side of the square cut from each corner. Okay, so what is the volume? Okay, volume, of course, would be length times the width times the height. Okay, because the base is going to be square, the dimension is to be 24 minus 2x times itself, or we can just write it as squared. Okay, and then multiply it by the height, which is going to be x. So express the volume V of the box as a function of the length x of the side of the square cut from each corner. Well, it's going to be this. Okay, that's your function representing the volume. Okay, and then for part B and C, okay, so let's look at B. What is the volume if a 3-inch square is cut out? So basically you're just replacing the x by 3 here and computing that out, and you'll get 972 cubic inches. Okay. Now let's clear this and go to C. For what value of x is V largest? So it's asking what is the maximum volume. Okay, and notice in this case we don't have a parabola. So again, using the graphing calculator, I go to, turn it on here, go to y equals. Okay, so I already have it entered. There's your volume function, 24 minus 2x, quantity squared x. Now let me deselect the first one then, so hit enter here. So deselect that one, and I want to select number y sub 2, hit enter. And now let's try to graph this. So if I hit the graph on this one, to look see what it looks like. Again, this is what you get, and typically you're going to get this type of situation, and when you're trying to do a graph when you have very large numbers or very small numbers. So what you want to do is try to find an interval. We know that the dimensions of the box are 24 minus 2x and x. Okay, since we're dealing with length, again, we want this to be greater than 0. Okay, so that would mean that 24 would have to be greater than 2x if you try to solve this inequality. Dividing by 2, we get x is less than 12. Okay, so again, we're dealing with length here, so again, that tells me that x has to be positive. X has to be positive, and it has to be less than 12. So again, we go to the window here. Okay, so we know x to be positive, and x has to be less than 12, so let's go ahead and do that. We'll let the x sc to be 1, we'll leave that at 1. We need y to be 0, and then the y maximum could be at 150. We try 150 here. See if I try to leave it like this. Okay, I get that. So let's go back to the window. And let's see, it's got to be some large number. play around with a function. I'm going to try 1300. Then I'm going to hit graph. And now I get something like this. Okay. So you can do a trace on this to make sure that the answer you want is located at this point right here. So if I do a trace here, so look at the values of y here at the bottom of the screen here. X equals 7.9 there. You can use the value of y. Okay, so we're getting close to 12. So at 12 it goes to 0, okay? So I know then that the answer I want does exist over here at the top of this curve right over here. So right there is going to be the answer going to come from that point right there. So I'm going to go to, again, calculate, so second, calculate, and again I want maximum. So hit 4. And I want it left bound, so I want it to the left of that point. I hit enter. Now go to the right past that point. Hit enter again. Again, the guess you can ignore. Hit enter. And you get 4. X equal to 4. So it says, for what value of x? For what value of x is v largest? Okay, so the value of x would be x equal to 4. That would be the answer to this part right here. Now, if it asks you what is the maximum volume, that would be the value of y, which is 1024. Okay, and that of course would be cubic inches. So, what value of x is v largest? And that would be x equal to 4, and that's in inches. And the value of the volume at that particular point, which would be the maximum volume, would be 1024 square inches. Cubic inches. And of course, we could also the answer to part B, which says what is the volume if x is equal to 3 inches? And I told you what to do, and I gave you the answer. But you could also do it this way. Go second, calculate here, and you want value, put a 1 there. And then, okay, you want the volume at 3, put a 3 there, hit enter. And there's the same answer that you would get if you just plugged it in. 972 cubic inches. Okay? Hope this helped you out. We'll see you in the next video. Thanks for watching.